on Earth? Where does the air get warmed? Let's think about at the equinoxes. At the equinoxes, where is the air getting really warm? At the equator. Because the ground is getting warmed by the insolation. And where is air really, really, really cold? At the poles. So if the Earth didn't rotate, this would be two ginormous convection cells. It's heated and rises at the equator, goes to the poles, and gets really cold and gets to the poles and makes its way south. It would be two ginormous convection cells, but that's not how it works, because what is the Earth doing?
Rotating.
It is rotating. So that's a side view of what would be the convection current in the northern hemisphere if the Earth did not rotate. Okay? But this is the real deal here. This is what really happens. Now, we don't need to know the names of the cells. There's the Hadley cell, the Ferrel cell, the polar cell, okay? But what we do need to know is where the winds are coming from, because that's how winds are named. Winds are named for where they come from. So, when we're looking at the winds on the Earth's surface, we're looking at the bottoms of those convection cells. This is what we've been doing in sea breezes and land breezes. This is what we've been doing in high and low pressure. This is what we've been doing in monsoons. We always look at the bottom portion of the convection cell, and those are the winds that affect us on the surface. All right, so here is a little model of a single cell. So here is the heating at the equator. So this is the Earth on its side, and that rising motion causes those clouds, and here's the sinking motion over here. So this is just the two cells that form at the equator, north of the equator, south of the equator. And then yesterday, hold on. Nope. Okay. And then here is another animation that shows the development of all of the cells as you work your way from the equator to the poles. Okay, so that's the first set of convection cells. Now, the Coriolis effect is going to be considered. So the winds are veering to their right in the northern hemisphere and their left in the southern hemisphere. And then the high latitudes, the polar winds. Now, they're called the polar easterlies because they're generally blowing from the east. And they're your jet streams. Those are those high altitude, very fast winds. Okay. Page 36 in our notes pack, just to wrap up global winds. All right. So you should definitely have out your ESRT because we're going to follow along in there. We're just going to kind of make a circle version only of this. So we're just going to look at the stuff that's inside the border of Earth, and we're going to make our own little diagram, right? Okay. So we know that if this is an equinox, we're going to say this is an equinox time of year. And we know that the sun, if this is an equinox, the sun is pretty much directly over the equator. So the equator is receiving the direct insolation. So at the equator, the air gets heated, becomes less dense, and rises, okay? And as the air is rising, something needs to take its place. So the air in this area is vacating the premises. What's going to rush in to take its place? Air from north and south of the equator. Let's do the southern hemisphere first. So this air in the southern hemisphere, in this area, wants to go due north. It wants to go due north, but it can't go due north because the Earth is spinning. So because we're in the southern hemisphere, this air that wants to go due north is going to veer towards its left. So that's what gets set up here. And where are these winds coming from? they're coming from the southeast. So these are southeast winds. All right. And let's turn it over. Let's go into the northern hemisphere. So the air in this area wants to go due north. It really does. It wants to fill in the air that's rising at the equator, but it can't. Can't go due north. It's going to veer towards its right. And let's go back to regular here. So where are these winds coming from? These winds are coming from the northeast. So these are northeast winds. So this air is vacating this area. This is approximately 30 degrees north. This is 0, and this is 30 degrees south. This air is leaving this area. It's diverging. So what is the air doing? It is sinking to take its place, right? As the air sinks, it's going to diverge. Okay, as the air sinks, it diverges. So now at 30 degrees north, the air is going to come down and go out in all directions. So this air is going to try to go due north, but it's not going to be able to because it's going to veer towards its, we're in the northern hemisphere, it's going to veer towards its right. And where are these winds coming from? Let's, to help us out, let's draw a compass rose. Where are these winds coming from? The southwest. So these are southwest winds. Okay, so that's sinking motion there. So this is sinking motion. What kind of pressure is associated with sinking motion? High pressure. And so this area is going to be dry. Sinking motion is fair weather. We still haven't gotten rid of this weather, right? Okay, it's moving really slow. That cold front's moving really slow. Okay, all right, let's go down here. At 30 degrees south, the air is sinking. The air sinks and it goes out in all directions. So it's moving away from 30 degrees south. The wind wants to go due south, but it can't because it's in the southern hemisphere and the Earth is spinning. So it's going to veer towards its left. You got it? Okay, let's go back to north up. So these winds are coming from that direction. So these winds are coming from the what? From the northwest. So these are northwest winds. And this area is also dry. Okay. All right. So now at 60 degrees south and 60 degrees north, before we do this, we're going to go to the North Pole and South Pole because I want you to understand what's happening. Okay. So at the North Pole and South Pole, it is really, really, really cold. Super cold. And because it's cold, the air is dense. What does dense stuff do? It sinks. Okay, so the air is sinking. The air is sinking at both the North Pole and the South Pole. And that sinking air at the North Pole wants to go due south, but it can't. What's the Earth doing? It's spinning, right? And there at the South Pole, that dense air at the South Pole is sinking. And it really, really wants to go due north, but it can't because the Earth's spinning. So this air at the South Pole that wants to go due north, but it's in the southern hemisphere, so it's going to veer towards its, you got it? And this air is coming from where? So these are southeast winds. And let's turn it over so we can be the wind. Get in the map. Okay. So these winds here at the North Pole, they're dense. That air wants to sink, and it wants to go due south, but they can't. They're in the northern hemisphere. They're going to veer towards their right. Okay, and these winds, let's go back to north up. It's better for our brains. Okay, these winds are coming from where? From the northeast, right? They're coming from the northeast. So these are northeast winds. Now, these winds are named for where they come from, right? No doubt. Winds are totally named for where they come from. But these winds also have other names. I think you learned about that in the video last night, didn't you? Okay, so these winds are coming from the northeast, but these also have, and these are coming from the southeast, but they have another name. What are they called? They're also called the polar easterlies. And so are these. They're coming from the southeast, but they're still easterly. So these are also called the polar easterlies. Okay. And these southwest winds here, they have another name. They're from the southwest, but they have a name known as the westerlies. And these are all, down here, these are also called the westerlies because they're from the northwest. Okay. And then once upon a time, when ships were leaving Europe and they were coming to the New World, right? They were sailing ships, right? So what did they depend on? Wind, right? So many times, well, in the summer, you know what happens. And they would rarely try to travel to the New World in the winter, right? Because the weather is just awful. So they would travel in the summertime. But you know this whole thing shifts up in the northern hemisphere summer, right? Okay. So this 30 degrees north kind of shifts up a little to maybe about 38-ish, 38 degrees-ish, 40. And so when they were sailing to the New World, they would use these winds. And then when the New World was discovered and they started trading, they gave them a name. What are these winds called? These are the northeast trade winds. So sailors knew back then that, hey, when we're going to the New World, we need to take a southerly route. But when we're coming back to Europe, we need to take a northerly route. Now, if they were to get stuck in here in this high pressure, if they were to get stuck right in here with that high pressure, there would really be very little wind. And many times they would be carrying horses on board, and they would just sit there and not travel, and the horses would eat a lot of food and drink a lot of water that they didn't have. So many times they would have to do what to the horses? They would have to throw them overboard. And so these latitudes in here where the sinking motion is, where there is very little wind, those latitudes are called the horse latitudes. I know. I know. Yeah. Right? Yeah. So there are certain latitudes where the sailing vessels would get stuck and there would be no wind and they would just sit there for days and weeks. It was bad. And they would run out of water. It was bad. There was no rain either. There was no rain either because why? Because it's sinking motion. Right? And so there's no fresh water, no food, no wind. They would be like, okay, we're sitting ducks. We're all going to die. Like, yeah, so those latitudes there. You did not want to get stuck in those latitudes if you were on a sailing vessel. Woo! Yeah, bad. Okay? So they do have other names. Oh, and these are the southeast trade winds. Okay. So this whole picture shifts. Okay, so if you're looking at this now in your ESRT, that's the picture there. Okay, so we have the side view of the convection currents. The bottoms are what these are. And you don't have to memorize these because what the names of the winds are right here for you, right? all the names of the winds are right here. And they tell you where the wet belts are because of the rising motion and where the dry belts are because of the sinking motion. Okay, so all the information you need is right here. I think it's just a matter of getting used to how this diagram is laid out. It's kind of, it's a little like, what am I looking at here? But that's what you're looking at. Side views on the edges, overhead views in the middle. Any questions? Okay. Stop that.